So this is 7.3b, college trigonometry, the law of cosines. Continuing on, we're going to do this first example, example 1. And we've got this handy dandy little picture here, so let's go ahead and see what we've got here. A surveyor wishes to find the distance between two inaccessible points, A and B. So we're going to find the distance between A and B. While standing at point C, she finds that AC is 259 and BC is 423. And angle ACB is 132 degrees 40 minutes. Find the distance between A and B. Now, you ever out on the road and you see these guys looking through this kind of like a telescope thing? They're doing surveying. It's using this trig in order to figure it out, although calculators and computers do most of the work nowadays. But you can find the distance between here and here without actually measuring it. By standing here, getting this angle, knowing this length, and knowing this length, you can find that length using the law of cosines. So we're trying to find the distance AB. So we're just going to call it AB. I mean, we could call it any number or any letter we want. We could call it X if we want, but let's call it AB. So AB squared, remember the law of cosines, middle of page 294, equals one of the other lengths squared plus the other length, it doesn't matter obviously which order, minus 2 times, again, these lengths, but we're not going to square them this time, we're just going to multiply them. And then cosine of the angle opposite this line. Cosine of 132 degrees 40 minutes. So you're probably going to have to change that 132 degrees 40 minutes into a decimal, change 40 minutes to degrees, so that's what, 0.67, and so 132.67 is what you've got there when you change 40 degrees to a decimal. You think your calculator will do that on its own. Use a calculator, you find out that AB is 628 meters. Okay? So, not too terribly difficult, but obviously they're going to get a little bit tricky as we go on, and this looks like it's going to be kind of a long lesson, so we'll see how we do here. Alright, let's look at example number 2. So here is example number 2. There's the triangle. We are given side, angle, side, so we will be using the law of cosines to solve this. And we're looking for everything we don't know. So let's go ahead and use the law of cosines to find A. So we're going to do A squared equals B squared plus C squared minus 2BC, oops, why did I put sine? Cosine of A. Okay? And then you just go ahead and solve that, and we find out that A is 10.47. And one of the things that's important here is we just found out that A is 10.47. And one of the things that you need to know, once you use law of cosines, you don't have to be worried about the ambiguous case of the law of sines. If the law of cosines works, you're going to have a triangle. So you can just ignore, oh man, I wonder if this is actually a triangle. It will be. Alright, so of the two remaining angles, B and C, B must be smaller since it is opposite the shorter of the two sides. So notice that this one is going to be the smaller between this angle and this angle because this line is smaller than this one, and they always follow the case. The shorter line, the opposite angle, is going to be, the smallest, the middle one, or the largest. And in this case, This one is the middle one, but it's going to be smaller than this because this line is smaller. We also know that A is going to be the smallest because this line is the smallest. This is going to be the largest since that one is the largest. So B cannot be obtuse. We know that. Okay. So let's go with my law of sines. Sine of A over A equals sine of B over B. That's an equal sign. So we've got sine of A, which is 42.3. We have our length A, 10.47, and that equals the sine of B, because that's what I'm going to be looking for in this one. Just decided to look for that one, and 12.9. So you do your cross multiplication, and you end up with B being 56-ish degrees there. And then it's obvious what that one's going to be, 180 minus 56 minus 42.3. So no work there. So we found our A, found our B, and we'll know our C then. So that's really all we need to do for that one. Let's go on to example 3.